All right, guys, welcome back. Let's talk about exponential decay today, okay? So last time we met, we talked about exponential growth. Today we're going to be graphing exponential decay, and the graph looks like this, okay? Now, the main difference to get this graph, we still have the exact same equation, but this time the b value is going to be in between 0 and 1. So it's going to be a fraction like 1/4 or 1/2 or something like that, okay? And I want to show you something. Think about it like this. As we read a book, don't you read the words from left to right? So it's the same thing with the graph. You read the graph from left to right, more or less. And as you go from the left to the right, look at the distance between the x-axis and the graph. Look at the distance here. It's fairly big, isn't it? About 5 spaces, okay? And now if you look here, as we go to the right, the distance from the x-axis to the graph is getting smaller. Now it's about 2.5 spaces. From here, it's now about like 1 1/4 spaces. From here, now it's about, I don't know, 2/3, okay? The distance gets smaller and smaller as we go to the right, okay? So that's decay. So if you think about, like, say this is graphing showing the amount of, I don't know, material, like lettuce or something. Let's just say lettuce, okay? Let's say you throw a piece of lettuce in the trash, okay? And when you first throw it into the trash, you have this amount of lettuce, right? And as time passes, look what's happening to the amount of lettuce. It's decaying and it's disappearing. It's probably turning to water or something like that, liquefying, okay? And you don't have much of the lettuce anymore, okay? So that's decay. All right, so let's get into this. Let's do our first example. We have y equals a times b to the x, okay? Notice that there's no h, there's no k, all right? So there will not be any sort of shift up or down or left or right, okay? The asymptote will be on the x-axis. It will just be y equals 0 for the asymptote, okay? And let me just remind you here that the b value has to be in between 0 and 1 for this to work, for it to be decay, okay? All right, so let's do our first example. We have y equals 2 times 1/4 to the power of x. All right. And again, there is no h or k, so I really feel like the best way to do this is to just make a t-chart, okay? X and y. All right, and I like the values -2, -1, 0, 1, and 2, okay? They don't always work, but I don't know, I usually get started there, okay? So now plug in -2, okay? So 1/4 to the power of -2. Well, remember the negative power flips this, it turns it into the reciprocal. So if I apply the negative to the power here, this 1/4 will turn into a 4. So it's really 4 to the power of 2, which is 16, times 2 is 32. All right, so 32. All right, let's plug in the -1. 1/4 to the power of -1. Well, just flip it, you get 4. 4 times 2 is 8. Okay. 0, plug that in. Anything to the power of 0 is 1. 1 times 2 is 2. Okay. And plug in the 1. 1/4 to the power of 1 is 1/4. And 1/4 times 2 is 1/2. Ah, there's my first reciprocal. We don't need to do any more work. Does anybody know what number's going to go there? All right, good. It's 1/8. Okay. All right, and if I wanted to, let's go ahead and put a third spot here, or x equals 3. What's that guy going to be without doing any math? Okay. You guessed it, 1/32. Okay? All right, let's go ahead and graph this. Let's see. All right, so we have negative 2 comma 32. So negative 2 comma 32, it's way up here. Okay, I'm not gonna bother with that one, okay? Negative 1 comma 8, so negative 1, 1, 2, 3, 4, 5, 6, 7, 8. That's right there. 0 comma 2, 1 comma 1/2, 2 comma 1/8, and 3 and 1/32. Okay, so you can see my decay right there. So connect the dots. All right, and again, you can see my asymptote is y equals 0. That's because I don't have a k. Remember, if there was a k here, that would move my asymptote up or down. So there's actually a plus 0 right here that you don't see. You don't need to write it. Just be aware that that's your asymptote right there. Okay? All right, let's do B. All right, now we have the more complicated ones. Y equals a times b to the x minus h plus k. And again, b is in between 0 and 1. And here is the example I will use. Y equals 3 times 1/2 to the power of x plus 1 minus 2. Okay. All right, and we'll go ahead and use our calculator for this. All right, so we'll plug that in, turn it on, clear this guy, hit y equals, clear whatever is there. All right, so now I'm going to copy it exactly as I see it. So I see 3 and then I see parentheses, okay? And then 1/2, you could put 0.5 or just put 1 divided by 2 and then hit your parentheses again, okay? Then raise it to the power of x plus 1. And then arrow out of that and then minus 2, okay? And then we'll hit our table. All right, so now I remember in one of my classes, a student asked, how do you know, like over here I put negative 2, negative 1, 0, 1, and 2. How do you know not to do that, okay? And I think what I tried to say was, hey, remember, there was a shift right here, remember? The negative 2 shifted everything down, and then this guy right here, which direction does that shift everything in the x direction? It shifts it to the left 1 place. So, wouldn't it make sense if I did my t-chart? Okay. X and y. Instead of putting negative 2, negative 1, 0, 1, and 2, if I'm shifting everything to the left 1 place, what would be a better x value to use instead of negative 2? Hopefully you said negative 3. If I'm shifting it to the left 1 place, that's negative 3. Then negative 2, then negative 1, 0, and then 1. I don't even know. Let's see what happens, okay? All right, so I'm going to go in my calculator here. And if you look at these numbers, they're really big. You don't necessarily want to graph negative 422. But look at this, negative 3 comma 10. Hey, we can actually graph that. So I think we're doing pretty good. All right. All right. So let me set up my graph, and I'm going to set up my asymptote too. Okay. All right. My asymptote happens to be what number? That's right. It's negative 2. Okay. So I'm going to just try to center it like this. I guess it doesn't really matter actually. I think I found that out in my last video, so I'll just go ahead and do this. And then my you guys can't even see that, can you? There we go. My asymptote is negative 2, so down 1, 2. So it's right through here. Here's my asymptote. Okay. And I usually put little arrows on it like that just so you can see that it's different than the axis. All right, and let me just copy down these numbers. -3, comma 10. All right, can you guys see those? -2, comma 4. -1, comma 1. 0, comma -0.5. And 1, comma -1.25. All right, and then now just plot the points. -3, 10, so 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's way up here. No big deal. That's fine. We can handle that. All right. -2, comma 4. So 1, 2, 1, 2, 3, 4. Okay. -1, 1. 0, -0.5. And 1, -1.25. So 1, -1.25 is right here. Okay. So you can see the curve. We could actually go out if we wanted to. Watch this. Put 2, okay? And if you look, 2 is -1.6, okay? So -1.6. So we can graph that too if you wanted to, okay? If you don't trust yourself, so go out 1, 2, and down -1.6. It's right here. You can see that it's getting closer to that asymptote, okay? I don't really care how many points you plot, if it's 3 or whatever, just as long as you see where that shape is going to be. So I'll go ahead and connect these dots. Put a little arrow here. All right. And that just goes real close to that asymptote there. Okay. All right. So that's the gist of it. All right. If you need anything else, just get a hold of me. You know where I'm at. I'm always hiding around somewhere on Zoom or, at my work desk. All right. I'll talk to you guys soon. Peace.